Hi students, welcome back. Today we are going to solve the lowest common ancestor of a binary tree problem on LeetCode. So let's look at the problem statement first. The problem statement says we are given a binary tree and we have to find the lowest common ancestor of the tree. Okay, so there is some definition given for the lowest common ancestor. So we will be given a root of a binary tree and two nodes P and Q. We have to find the lowest common ancestor of it. And there are some constraints as well. The P and Q will never be equal. Both of them will always exist in the tree, and all are unique nodes in the tree. So we don't have to check for a lot of corner cases. Okay, now let's look at what lowest common ancestor means. And so lowest common ancestor is uh, defined between two nodes P and Q as the lowest node in T that has both P and Q as its descendants. So the nearest parent of both P and Q is what is lowest common ancestor. So let's look at the example. So if this is the tree given and P is 5, Q is 1. So the nearest neighbor for both of them is, nearest parent for both of them is 3. So the answer is 3. Now, if you look at this tree with 5 and 4, so the common parent for both of them is 5 itself. Okay. So if 1 and 2, 1 and 2, so here again it is a tree with two nodes and we are looking for both of them. One of them is in the path. So that will be the answer. So basically we have to find the nearest parent of both the nodes. It can be a case where the parent is the node, one of the nodes itself too. Okay, so let's look at it through an example. So let's say we are given this tree. Okay, and uh, if we are looking for 6 4, okay, we are looking for 6 4. So one way is to find the path of 6. What is the path of 6? 3, 5 and 6. Find the path of 4, which is 3, 5, 2 and 4. What we can simply do is the point at which these two diverge. That is, uh, initially the two paths have 3 as common, 5 as common. At this point, they are diverging, which means this is the lowest common ancestor. That is one approach. But there is a much easier recursive solution. Let's look at that. So what we will do is we will keep looking for these nodes in the tree. Okay. As soon as we find the node, we return that to the parent. Okay. So here is 6 and 4 available, either 6 or 4 available here? No. So then we will keep looking in the left and right. Is 6, so we'll first go to the left. Is 6 or 4 available here? No. Is 6 or 4 available here? Yes, 6 is available. So we will return 6. Okay. Now for this node, node 5, we have to process the right also. Left processing is complete. Now is 6 or 4 available here? No. For this node, we have to go to left. Is 6 or 4 available here? No. So this returns null. Okay. Now it goes to the right. Is 6 or 4 available here? Yes. So this will return 4. So at node 2, left return null, right return 4. That means it found the node on 4. We are looking for the nodes. So 2 will return 4. Now, if you observe 5, it found one node on the left, one node on the right. So, it will return itself. That means it is the common parent for 6 and 4. So, 5 has found the nodes, one on the left and one on the right. Earlier, if you see 2, it found only one of the nodes. 2 has 4 on the right, but left is null, which is why we returned 4. As soon as we find nodes on the left side and right side of its tree, that is its common ancestor. So we will return 5. Now we finish processing left side of the tree. We go to the right. Is 6 or 4 available here? No. But it has children. We'll go to the children. Is 6 or 4 available here? No. It's not available, so this will also return null. Now it will go to the right. Here also not available, it will return null. Both left and right are null. It will return null. And at 3, left has returned 5 while right has returned null. So it will return 5. So that is our recursive solution. So what we are saying is we will traverse the tree looking for either P or Q, which is 6 or 4 in this example. And as soon as we find one of them, we will return that. If we don't find anything, we'll just return null. Okay. If we find both of them on the left and right, that means that node is the common ancestor. We will return that. So there are a few cases here. One is both left and right are null. In this case, we haven't found anything. Both left and right are null. So in this case, we will return null, which means we haven't found anything. There is a case where either left or right is not null. Okay. In this case, we found a element in one of the element in either the left side or the right side, which means we have to return the not null element. Okay, whatever we found, we have to return. So we have to return the right, not null one. It can be either left or right. So if one of them is not null, we will return that. If both are null, we will just return null. Now, what if both are not null? Left and right are not null. If both are not null, that means on left you found something, on right you found something. In this case, we have to return the current node, which will be the common ancestor, lowest common ancestor. Okay, that is how we will solve this. So these are the three simple cases that we have. If both are null, it is just null. If either of them is not null, we return that not null element to its parent so that it will help it compute the lowest common ancestor. Once we found both left and right as not null, that is when we found the answer. So at any point, if you are looking for a lowest common ancestor, which is a parent, right? And it's a binary tree. It has only two children. So for it to be a parent, it has to come from left and right. And our question clearly said P and Q doesn't have same values and doesn't repeat. So it should exist definitely. One of them should definitely be in left and one of them should definitely be in right. That is what we are using here. So these are the three cases that we should code for. So the overall algorithm is we will keep looking for either P or Q. Once we find either P or Q, we will start returning that. Okay. So there are three cases for returning. So one is you didn't find P or Q in the left side of the tree or the right side of the tree. Then you will return null. You found either P or Q in one of them. That means either in left or right. Then you will return the whatever is not null. If you found P and Q in both left and right, that means P is on the left, Q is on the right, or P is on the right, Q is on the left. In that case, whatever node we are at, that is the lowest common ancestor and we will return that. Okay, that is a simple algorithm. So let's see how we can write code for this. Okay, so what we have is a root node which gives the root of the tree, a node P and node Q. So let's write the corner cases first. If root is null, there is nothing to do. Okay, we just return root. Okay, then there is, if we find a node, that means if root dot val is equal to p dot val, or root dot val is equal to q dot val. If this node is whatever we are looking for. If this node is either P or Q, we have to return that node. That's what we talked about. Okay. Otherwise, we have to keep looking for it in left or right. So far what we have done is we checked if the current node that we are at is either P or Q. We are just looking for either P or Q because it clearly said in the question that P is not equal to Q. They are all unique values and all that. If there are repeated values, then we'll have to handle more cases. But since there are no repeated values, we can just say if you find either one of them, just return that node. Okay. If you didn't find it in the current node, now what you have to do? You have to look for it in the left side of the tree. Okay. So we have to look for it in the left with root dot left. Okay. And we have to look for it in the right. You have to look both left and right. You didn't find it in the current position, so you look for it in left and right. Now we have all the cases that we talked about. Now one case is where you find the parent. If left is not equal to null and right is not equal to null. That means the current node is our lowest common ancestor. So we return the current root. Else, if left is equal to null, that means we return right. Okay. Otherwise, we return left. So this also covers the case where both left and right are null. So if both left and right are null, we have to return null, right? So we are returning right, which is null, so it will return null. So if left is null, we are returning right. If right it is null, we are returning left. If both are null, we are returning null. These two lines will handle all the three conditions. Okay. This is what we have. Let's submit this and see. Yeah. So what we are saying is first checking whether the node we are at is either P or Q. If it is that, we return that. Otherwise, we look in the left side, we look in the right side. If we found it both in left and right, then our current root is the lowest common ancestor. If we found it only in right, then we return right. If we found it only in left, then we return left. If we didn't find it either in left or right, we return null. Okay, that is a simple case. So here we are looking for each node in the tree at least once. So the time complexity is order of n, and due to the recursion stack, the space complexity would also be order of n. So the same problem, if you try with the binary search tree, it would be even more simple. So in the question, what we have is a binary tree. So binary tree only guarantees that it has two nodes, but it doesn't specify the order. Like in binary search tree, you have right side of the tree is always greater than the root, left side is less than root and all. So if you try to do the same problem with binary search tree, it would be even more simpler. Give it a try. Thanks for watching. Happy coding.